Hi friends, now let's look at subtracting integers. And as I mentioned in the previous video, when it comes to subtraction, we will think of this as adding the opposite. Now that we've got integers in our toolbox, positives and negatives and zero, we can use this idea. We could have been using this all along, but it would have been a little premature to be thinking about subtraction as adding the opposites before we really dive all the way into integers. So now let's do it. Let's take a familiar example like 9 minus 4. Just a good old-fashioned subtraction problem. And when we say that instead of subtracting, we will be adding the opposite, this is how it plays out. And again, it's something where it could play out in a couple of different looking ways, and you'll want to identify what is the way that feels comfortable for you and leads to good, consistent, and accurate results. So this problem is 9 minus 4. It looks like there are two positive numbers, 9 and 4, and the operation between them is a subtract. So we generally will keep that first number. It is what it is. It was a positive 9. It is a positive 9. So maybe I could say it is what it was. But the minus 4, there's where we need to make a change. We don't want to deal with subtracts. So instead of minus 4, let's even just write out minus 4, we want to not subtract, not do a minus, we want to add. And not add 4, it would be the opposite of 4, add negative 4. This is something we can always do with any subtraction problem. 9 minus 4, it's a little crowded, let's make some space. 9 minus 4 is going to be exactly the same, equivalency-wise, as plus negative 4. They will give us the equivalent answer. Now this might not be a way that you look at a problem like 9 minus 4 because you've been doing that for a long time, and you would say, I know that it's 5. I start with 9, I take away 4, it equals 5. But this will be an important move that we do a lot in the future. So we're going to begin to do it when we see subtracts. Minus 4 means plus negative 4. And now bring back all those ideas about the number line, the money example, the zero-sum pairs. Any way where we can see that 9 plus negative 4 would equal a positive 5. I'm going to begin to focus on the money example. I'm going to get paid 9. From that 9, I have to pay back 4, so I'm still going to be left with some money. I'm going to be left with $5, so my answer is a positive 5. Some people like to look at this problem in a little bit of a more informal kind of way, and it's something that's, if it doesn't feel right now, just don't think about it. But as you go further into algebra and begin to have situations where we need to put together integers with some variable expressions, you may begin to see this pattern emerge more and more. So why not get a peep at it right now? Same idea that the first number stays the same. So there's a positive 9, it is what it is. Then any operation or operator that we see, like that minus symbol, we begin to understand that it really is a part of the number that's right behind it. So 9 minus 4 really is like that 4 is taking on the minus and becoming negative 4. And it's like we just changed that little dash from meaning subtract to meaning negative. And it is that sort of, it is legitimate. It does lead us to an accurate place as long as we remember that once we do that move, take the sign and attach it to the number that's right behind it, that what is left behind is an addition of those two things. I put parentheses on both to really make it clear. So when I see subtracts, I think that subtract really belongs to whatever number or term is right behind it. So 9 minus 4 is saying 9 and negative 4, and they're added together. So for now, we will focus much more on, instead of subtract, add the opposites because that's really the more concrete idea. But you may begin to notice this pattern, and you'll be able to notice it pretty consistently, how the problem changes its appearance when we go from a subtraction to an addition of the opposite. So let's take a few more examples to really get this idea feeling more comfortable. Let's take this example, -3 minus 5. I do not want to begin thinking about number line or the money example or the zero-sum pairs, because I want to have those thoughts when I'm looking at an addition problem. And I'm not there yet. This is a subtraction. So we want to make a change first. The first number, it is what it was, -3. But when we get to this subtract 5, here's where we will not subtract 5, we will add the opposite of 5. So add -5. There's that change. There's our change from do not subtract, see a subtract 5, but know that what we want to do is we want to add the opposite. Opposite of 5 would be -5. Now bringing in our examples like number line, money example, zero-sum pairs, any of those should put us on a path to see that -3 plus -5 equals -8. Number line would be go to -3 and then to the left by 5 units. Money example, I owe $3 and then I owe 5 more, so now I owe a total of $8. With the visual aids, this can get a little interesting, so let's pause for a minute and break this down a tiny bit. We saw several examples before where we would say, okay, there's how we can show -3, 3 red units, and then adding in -5, so putting in there 5 more red units, and we see that we have collected a total of 8 red units, so -8. Let's see if we can use the visual aids to actually show how the subtract would get us to -8, just so that we can really show that all the different ideas do connect. We're not changing rules around or anything. So how can we show with visual aids -3 minus 5? Well, actually, the first thing that we'll do is we're going to keep all 10 of these pairs in the mixture, in the picture. And let's see, we're going to start with -3. So the first thing I'm going to do is just block out the things that we don't need to see. Remember, anything that's in a pair is 0. So all this stuff down here, it's all paired up. All of that equals 0. So I don't need to wonder what that part amounts to. It's all paired up, it equals 0. The leftover is right here, 3 red units. So there's how we can show we're starting with -3. I got 3 reds, and then I have plenty of other pairs here that currently amount to 0. They're just hanging out. So it cleaned out a little bit of the clutter, but remember those pairs are all 0. Those 3 reds there are our -3. Now subtract 5. Okay, we're breaking away from the addition thinking and just seeing how can we represent the subtraction. Well, subtracting a +5 would mean let's take away +5. Take away 5 of the green units because those are positives. So let's take away 1, 2, 3, 4, 5, all taken away. And where are we now? Our zero-sum pairs are down here, all zeroed out. And left over, now we can see 8 reds, -8. So everything still connects and is legitimate. They're legitimate moves. But to get into a good rhythm for much larger problems and a lot of future problems, we're going to consistently change our subtractions to adding the opposite. But even with our other manipulatives and tools, we can show that subtracting does get us to the same answer. -3 minus 5 does equal -8, shown with visual aids. Punch it into a calculator, it's going to show you, but we're going to get into a practice because it allows us to use those properties of putting things in any order, which can be a really big help for solving some problems down the road. Let's tackle a couple more examples. Now we're looking at -9 minus -2. All right, things are starting to maybe feel and look a little bit cluttered. Lots of symbols, lots of minus signs going on. Well, what's important for us to recognize, we don't have an addition. So we're not ready to get into those main concepts yet. Money example, number line, zero-sum pairs. We have to think about where's the subtraction and how can we change that from a subtraction to adding the opposite. First number we don't change, -9. Here's our subtract. We've got minus a -2. So we need to add the opposites. Opposite of -2 would be a +2. If you're thinking about, oh, there's a rule, right? Two negatives make a... Keep thinking about those rules. When you get to and through some problems on your own, reflect on those rules and say, do I have a good rule here? Can I articulate it in a clear way? Does it work every single time? That's good. That's great for the learning process. But as I said earlier, I don't like just laying out the rules, especially at the start. So I acknowledge that you may be thinking about that. Continue to think about it. I don't want to weigh in on it at this time. So minus -2, change that to add the opposite, so add +2. Now we've got the nice addition. I'm going to a money example. I owe $9. I'm going to get paid $2. So I'll still owe $7 after all that happens. Number line, go to -9, add 2, that's a +2, so we move to the right. That also takes us to -7. Zero-sum pairs, why not? Just for consistency and to be comprehensive with our answer, there's the 9 red units for -9. 2 green units for +2, some zero-sum pairs, and it leaves behind 7 reds for that answer, -7. If you're curious about how can we make it work with -9 minus -2, let's give it a try. So let's start with -9, but we're going to keep behind some zero-sum pairs. So I'm getting rid of all of these extra greens. So I can really show you I've got 9 red units right there. There's my -9. And I have a zero-sum pair down here. I might even need more depending on the numbers in the problem. So I'm just going to keep that zero-sum pair for now. But we remember this equals 0 down there. So whether it's there or not, I'm showing you -9. Now we want to take away -2. So from this image, we need to remove some negatives. We need to remove 2 negatives. So let's do it. There's one negative, there's another negative that we've removed, subtracted out. Now, we didn't need that zero-sum pair down there at all, so let's wipe that out also. And what are we left with? 7 red units for our answer, -7. So just for closure, for consistency, to be comprehensive, we show how the visual aid does work with subtract, but we will continue to get in the habit of not subtract, but add the opposites. Now let's look at one big beefy problem and apply all these ideas. Here it is. I might have gone overboard, but this will be a good problem to use for an example, apply a little bit of effort to it, and focus on what we've established so far. Additions we like. We can go to our happy place about money example, number line, zero-sum pairs. Subtractions we want to change. So let's start on the left. We'll scan this problem, and where we see the subtracts, we will make that change from subtract to adding the opposite. Here we go. We start with a -3. Then we have -5. So we change that to add the opposite, add -5. Okay, there was that first area of change. Don't get into this tunnel vision of like, okay, I change everything. I see something, I change it. Because what's the next thing we see? Addition. We like addition. Leave that one alone. Plus -2. You're perfect just the way you are. Next one is a subtract. -1. That's what we want to change. Not -1, but add the opposite of 1, which is -1. Keep going carefully, intentionally. I would not have an expectation that I look at this problem from the start and I know exactly what I'm going to do start to finish. I don't think that's realistic. So we just be cautious and intentional with each move. Additions, we keep them. So +4, no change. Now we have a subtract. We've got a -6. So let's add the opposite. Add -6. There was one of those minus negatives, but just go slow. Remember what we do. We change a subtract to adding the opposite. So not minus -5, but add +5, the opposite. And lastly, one final subtract -3. We change that to plus -3. All right, that was a bit of work, and it feels like the problem is the same size. Have I really done anything to try to get this thing answered? We've done a lot. You've really actually made this into a much more attackable problem by not having a mixture of adds and subtracts, but getting it all additions. For that main reason that we can do it in any order, but also this is a very common approach in future math problems. Big complicated ones with adds and subtracts. Let's see what it looks like with all only additions. It doesn't look like we've changed the problem that much, but we've really positioned ourselves well. So next, with all additions, we know we can do this in any order. It felt pretty productive last time when we could spot some zero-sum pairs right away, like a -5 and a +5. Some opposites right there, zero out. Do we have other ones? No, not so much. Not obvious ones or other ones. So let's not be too hasty and imagine that we always need to find like an easy way or short way or fast way, because that's not realistic either. So what's my comfort? Maybe I'm going to put together all the negatives and put together all the positives and then wrap it all up. Let's do that. That's my kind of comfort zone. So I see a -3 and a -2. I'm putting together only negatives, so it's like just a regular old addition, but I'm going in that negative direction. So my answer is just getting more and more negative. -3 plus a -2. So now I'm up to -5 plus a -1. So now I'm up to -6 plus another -6. So -6 with another -6. So now I'm up to -12. With another negative, this time a -3, so -12 with 3 more negative, I'm up to -15. And it looks like I'm marking it up just to make sure I'm taking care of all the numbers here. 1, 2, 3, 4, 5 negatives there were. 3 plus 2 is 5, plus 1 is 6. 6 and 6 is 12. 12 and 3 is 15. So all those negatives together does take us to -15. There's only one positive here, that +4. Okay, now money example, number line. I owe 15. I'm going to get $4 back, but I'm still in the hole. I'm still with a negative result. I owe 15, I get 4, that leaves behind 11 that I still owe. So big beefy problem has this answer, it equals -11. So make sure that you get a chance to try out many different kinds of problems of adding and subtracting integers, focusing on these ideas, our main concepts when it comes to adding, and that when we get to subtracting, we just not subtract, but we add the opposite. And now we're back in our comfort zone, applying those concepts that we're developing. So take some time to practice, and stay tuned for the next one about multiplying and dividing.